Hello and welcome to XY Engineering and Technology Space. Today I'm just going to be showing you one of the services being rendered by XY Engineering and Technological Services. And today what are we looking at? We are looking at engineering simulation, and we are going to be taking a look at ANSYS. ANSYS is an engineering simulation and modeling software. It's one of the most popular softwares out there when it comes to engineering simulation and design validation. Okay, here we are, and this is ANSYS Workbench. From the analysis toolbox here, you can see the different analysis that we can perform. You can perform design assessments, buckling, load buckling for mechanical structures or systems. You can see we have electrical analysis, we have fluid flow, and some other analysis that you can carry out in real world. So today it's just going to be showing you what we can offer. I'll be opening one of the projects that we have done. So XY, while it's opening, XY Engineering and Technology is a firm, just like the name, for general engineering services and providing technological services from repairs, maintenance of laptops, desktops, sales, to offering trainings and consultancy. So we are a startup. We're trying to build. No great thing has ever been built in a day. Rome was not built in a day. So with your support, we know we are going to be giving the very best to the society. Okay, so I have here the simply supported beam simulation, and opening the results. We're going to be walking you through this simple simulation. This was just done for the purpose of it's not one of our works. For the sake of confidentiality, this is just a sample work that was done using ANSYS. Okay, here we go. This is ANSYS Mechanical, the mechanical environment, where we can you can see from the project toolbar, we have the model, which is this model of a beam. As you can see, this is the beam that was designed using ANSYS. It can be imported from other softwares, but since it's a simple geometry, we had done this using ANSYS, inside ANSYS. So if you have a preferred software, Autodesk Inventor, SolidWorks, Fusion 360, SketchUp, AutoCAD, you can import your model, your geometry. And the material we used was structural steel. You can see from the graphics window. Then the coordinate system is the X, Y, and Z, the 3D coordinate system. Then you can see the mesh that helps us define our computational boundary for this beam. Then some of the things we did, since it's a simply supported beam, one side has to be fixed, then the other side has to be able to should be displaceable horizontally. So you can see we just have displacements only in the x direction, while it is fixed in all that. It is fixed in the F, Y and Z direction. Then there was a force applied, a force of about 5,000 Newton. As you can see here, the force is 5,000 Newton. Then we have our solution, which is our result. So the equivalent stress is shown here. This is the stress. If a load of 5,000 Newton, in a layman's term, if a weight of 500 kilogram, why is it 5,000 Newton? Because acceleration due to gravity has been considered. So if it's added on a beam that is this long, the length is around, let's see the geometry. I think the length is about 5 meters, right? Yeah, I think it should be 5 meters. Yes. So if a load of 5,000 Newton is placed on a beam that is 40 mm thick, that's 4 centimeter, and around, okay, this is 1 meter, around 1 meter. This is the deformation you would expect if the material is structural steel. So you can see the deformation along the original path. Then we also have the directional deformation in the y-axis. As you can see, the red shows the maximum value and also the normal stress, which is the maximum is around 71.09 megapascals, which is showing you that at the center of the beam the stress would be more, which you can predict, right? So this is this simple simulation of XY Engineering and Technology Services offers simulation as this, and even training on how to perform real-life simulation, validate your designs such as this. Thank you for a wonderful time. Thank you for watching. Do well to recommend us, to share, like, and support us as much as you can. Thank you.